All right, this is a quick video for assignment number 6, section 9.5 in your books, which is operating and maintaining a vehicle. When you have operating and maintaining a vehicle, you have different things. You have variable cost. Variable cost, or cost of producing a product that vary directly with the number of units produced, such as raw materials and packaging. Also, vehicle costs that increase the more you drive, such as gasoline and tires. So, for what we're dealing with, the first part of this isn't really what we want. It's just the second part. The more you drive your car, the more these variable costs increase. Things like gasoline, oil, different tires, any kind of repairs, those are all variable costs. It's not something that stays the same all the time for the life of your car. Gasoline prices can go up, oil prices go up. The cost to get new tires goes up. Cost of stuff like, I know one of the things that's gone up a bunch here in the last few years is the cost of a battery for a car. They're very, very expensive now. So all those different things go up as you put more and more miles on the car. As the car gets older, those prices go up, so those are variable cost. All the different money you put in that could just change throughout the year. It's not something that stays the same. Fixed cost, production or vehicle cost, which remain about the same regardless of how much you produce or drive. Things that fit here, vehicle registration. It costs you about the same to get your license or your tags for your car each year, so that stays about the same. Maybe your payment for your car, so your monthly payment that you pay on your car, insurance for your car usually stays about the same. It could go up or down depending on different things, but it usually stays about the same. One other thing that stays about the same as the car gets older and older is the depreciation of the car. So each year, every year older a car is, it depreciates, or the value of it goes down, or the more miles you put on it, the value of it goes down, so that's depreciation. And that stays about the same for a life of a car. It not necessarily always going to be exactly the same, but close. So depreciation is the decrease in value of your vehicle from one year to the next because of its age, condition, miles on it. The more miles it has on it, the more it's going to depreciate, the more it's going to go down in value. So these are all things that go into owning and operating a vehicle. Things you got to remember. Probably the one that's the worst, you can sort of count on what your payment's going to be, what your insurance is going to be. That stays about the same, so you can sort of know, hey, I have to make this payment every month. I have to pay the insurance each month or every 3 months, however you pay it. But the ones that really hurt is when something goes wrong with the car and you have to repair it or put new tires on it. Those are the ones that really cause you trouble. Couple of formulas here, depreciation, and this should probably be annual depreciation because we're doing it by the years, how many years. So it's the purchase price, what you paid for the car, minus its value today, and then you divide that, once you subtract those two, you divide that by the number of years that you've owned it, and that'll tell you how much your car has depreciated per year in the amount of time that you've owned it. Cost per mile to operate your car. Take all the annual variable cost plus all the annual fixed cost and divide it by the number of miles. This is sort of hard to find unless you're a real, really well organized and you keep track of everything. I've tried to do this in the past and it just didn't work out real well. You know, you keep all your gas receipts, you keep all the money that you buy for changing oil in the car, or putting the money you spend putting new tires on the car, money you spend to buy a headlight for the car or a tail light bulb or whatever. And I've tried to do this in the past. It's really hard to stay organized and find all the annual variable costs. Your fixed cost, again, that's like your car payment, your insurance, how much it costs to put tags on it, so on, so on, so on. So those you can probably just look back at your receipts or your bills for the year to find that. And then number of miles, you just keep track of the number of miles. You know, like if you wanted to start today, then we would go for a whole year till next year, this same date, and figure out how many miles we had on the car just by subtracting how many were on it right now, and then next year how many you have on it next year. Normally, it used to be about 10,000, but the number of miles per year, it used to be insurance companies went, if you put 10,000 miles on a car in a year, that was about average, about normal. Now I think it's a little more. I think now it's up to like 15,000 miles per year, because it used to be, when I first got my license, if you put 15,000 miles on a car in a year, then the insurance company were charging you a little more because you were putting excess miles on it, or more miles than they thought you should be putting on it, so you're driving it a whole lot more, and then you would get charged more in insurance because you are using your car a lot more than what they expect it to be used. All right, this example, Robert Young purchased a car for $21,306 3 years ago. It is currently valued at $15,430. What is the annual depreciation for this vehicle? All we're going to do to find that annual depreciation is we're going to take 21,306 and we're going to subtract off what it's valued at now, which is 15,430. And once we get that answer, we're going to divide it by how many years he's owned the car, which they told us 3 years, so we're going to divide it by 3. Ignore that, it's supposed to be an equal sign. If I grab my calculator and I punch in 21,306 minus 15,430, hit equals. Make sure you hit equals first, because you got to let the calculator know, do that top part first. And then you're going to take that answer and divide it by 3. And so it's depreciating about $1,958, and we'll round that off to 67 cents per year. That's how much it's depreciating. So almost $2,000 his car is going down per year. So if he looks it up next year and he looks at the value of his car next year, he could probably expect that it's gonna go down about $2,000. So next year, it would be somewhere around, $13,400 is how much it would be worth. And then if it goes down $2,000 more or somewhere around that, the next year it's down to about $11,400. So it's gonna, not quite $2,000, I'm rounding off just to make it easy for me to do the subtraction here, but it's depreciating almost $2,000 per year. For the past 2 years, Deanna Vila has recorded the cost of operating her car. She has a total of $1,350 in fixed cost and $2,390.87 in variable cost. Remember, the fixed costs are stuff like her car payment, insurance, getting the tags for the car, so on and so on. Variable costs are gas, oil changes, new tires, any kind of other repairs on the car. She has driven the car 10,900 miles in those 2 years. She must not drive the car very much because that's pretty low. That's only a little more than 5,000 miles a year, and that's very low on a car. All we're going to do on this is we're going to use the other formula, and we're going to add up the fixed cost and the variable cost. So 1,350 plus 2,390.87, and we're going to divide that by how many miles she has driven. 10,900. Notice here, you can do this for 1 year, you can do it for 2 years, 3 years, 4 years. It doesn't really matter because you're getting how much it costs per mile to drive the car. So for every mile you put on the car, you can expect to spend this amount of money that we're getting ready to come up with. If I grab my calculator, again, you got to make sure you do the top part first and then do the dividing. So 1,350 plus 2,390.87. That gives me $3,740.87, and I'm going to divide that by 10,900. So divided by 10,900, and I end up with about 0.34. And what we're saying there is that it cost about 34 cents. 34 cents per mile to drive her car. And I know that doesn't seem like a lot, but if you think about how many miles you actually put on your car each day and stuff, so, if you drive out to Richmond and home and you put 30 or 40 miles, let's say 40 miles on your car, well, if you take that 40 times that 34, and I've grabbed my calculator here, so that trip out to Richmond just cost me about $13.60 on all the stuff on my car, or all the wear and tear and gas and everything for the car. One thing that I don't know if Deanna actually took into consideration on this is the fixed, whether this included the depreciation of her car or not, which it should. That's got to be figured in, or that should be figured in there also, but it doesn't look like that it was figured in this problem. All right, the assignment, and again, this is assignment 6, is page 356, problems 3 through 10. And what I'm going to do, I'm going to let you do 3 through 8 on your own. Those are using the 2 formulas and all that stuff. 9 and 10, 9 is a challenge problem, 10 is an algebra problem. Those are the ones that you guys usually have trouble with. So I'm going to go ahead and do them on here, and you can just transfer them over to your paper when you send it back to me. So problem 9 says John Baker is considering 2 cars. The first is a new 4-door, 2.3 liter 4-cylinder gas engine sedan for $21,735. The gas engine sedan gets 21 miles per gallon in the city driving and 31 on the highway for highway driving. The other is a new 4-door, 2.3 liter 4-cylinder gas electric hybrid sedan for $27,040. Its miles per gallon is 33 in the city, 34 on the highway. John drives about 15,000 miles per year, equally divided between the city driving and the highway driving. He decides to buy the hybrid. If he can get gas for $4.08 per gallon, this must have been when gas was really, really high, how long would it take for his gas savings to match the price difference? So this is deciding whether you're buying a hybrid, which is part electric, and this was back when the hybrids, when our book was put out, was back when the hybrids weren't the greatest. They're getting better, but they're still not spectacular. So you had to decide, or you got to decide whether the extra cost for the hybrid is worth it to you in the long run. So it says John, he bought the hybrid. We're going to take $27,040 minus, that's a minus, $21,735. That's going to tell us how much extra he paid for the hybrid rather than buying the gas car. So 27,040 minus 21,735 is $5,305. So that's how much extra he paid. That's the money that we want to make back by buying the hybrid and saving in gas. There's several different ways that we could do this. The answer that the book came up with was like 12 and a half years, and I can't figure out how they got that answer because when I give my answers, it's closer to like 10 years. So we're just going to go with, I'm going to show you how you can, one way you can do it, and it's going to give us an idea here. So the first thing, they say that they drive, or that he drives equally on the highway and in the city. So if he's driving 15,000 miles in a year, then that means about 7,500 per each. And all I did was I took 7,500 and I divided it by 21 because it said he got 21 miles to a gallon in the city. This is for the gas car. And then we'll also do the hybrid plus 7,500 that he drives on the highway divided by 31. If you punch that into your calculator just like that, this is going to tell you he get 21 miles per gallon here, 31 miles per gallon here. This is going to tell you how many gallons of gas he needs in that year to drive the gas car, and I came up with about 599. So 599 gallons is what he needs for the gas car, to operate the gas car for the year. Then I'm gonna do the same thing for the hybrid. 7,500 divided by, it said that he got 33 miles per gallon in the city and 34 miles per gallon on the highway. I punched all that into my calculator and I came up with about 448 gallons. So he's gonna need about 400, for the hybrid, he needs about 448 gallons per year to operate the car, to drive his 15,000 miles. And then different things you could do here. We could have averaged these together and just did the 15,000 with an average. The average for 21 and 31 would be 26 miles to the gallon, so he's averaging, getting about 26 miles to the gallon. And it should come out about the same. That's why I'm confused on how the book got their answer. So if I do this, that means that he needs, we could take these two numbers and he needs 448, we subtract those two. He needs an extra, or he would have needed an extra 151 gallons of gas to operate the gas car. So that's actually gallons that he's not gonna need because he bought the hybrid. And if we take this number, and they said he can get gas for $4.08, we multiply those. So I grab my calculator, 151 times 4.08, and I get $616.08. So he's saving about $616.08 per year. That's what he's saving per year. And the gas that he doesn't have to buy. Well, then if we take the 5305 and we divide it by that, that's going to tell us, if this is per year, that's going to tell us how many years it would take for him to make up the extra money that he paid for the hybrid. So if I grab my calculator and do 5305 divided by 616.08, I end up with about 8.6 years. And then again, the book's coming up with something like 12 and a half years. I'm not sure how they're getting that many years, but that's what the book is saying. If somebody figures out how the book got that answer, please let me know. I did it a different way where I didn't round off as much and stuff on my calculator, and still the most I ever came up with was about 10 and a half years. So I'm not sure how the book's getting 12 and a half. But I would say in 8 to 10 years is the range there. So that's the answer to this. How many years is it going to take for him to make up the money? In 8 to 10 years, he'll make up the extra $5,000 that he spent buying the hybrid. Number 10. Number 10 says, Rachel Kaufman drove her SUV 17,600 miles last year. If her cost per mile is 47 cents and her annual variable costs were $48 more than her fixed cost, find her variable cost and her fixed cost. So we're going to find both those, and what we're going to use is the formula, and the formula was cost per mile equals the variable, and this might be written in a different order than what I put it on the notes, but it means the same thing, variable plus the fixed cost divided by the number of miles. And all we're going to do is plug into that formula, cost per mile. This time they told us that the cost per mile was 47 cents. What we don't know this time is we don't know the variable or the fixed, but they tell us that the variable is $48 more than the fixed. So what I'm going to do is I'm going to let the fixed just be some variable. We'll use X, that's an X. And then that means the variable is going to equal $48 more than that, or X plus 48. And that's what we're going to stick in here. So for variable, it's X plus 48 plus the fixed, which is just X. And the miles they told us were 17,600. Now we're just going to do a little bit of math here. First thing I would do to make this easier is multiply both sides. So we're going to times both sides by 17,600, because that's just going to get rid of that bottom number. And then that means we got to times this side by 17,600. So we take 0.47 times 17,600, and we end up with 8,272 equals, and we still have what's on top over here. And I'm going to drop these parentheses because they're sort of unnecessary. So it's X plus 48 plus X. Well, we can combine the X's. So that's going to be 2X plus 48. Then I'm just going to solve this the rest way out. Subtract 48 on both sides. Ignore all that. So we got 8,272 minus 48. That gives us 8,224. These cancel out. Leaves us with 2x over here. We divide by 2. So you just take that 8224 divided by 2, and we end up with 4,112. These cancel out. That's x. So now when we go back over here, that means our fixed cost were $4,112. That's one of your answers. And our variable cost, all we do to find the variable cost is we add $48 to that, and you get 4,160. So those are the two answers for number 10. Again, finish this, send me a picture.